Hello there. My name is Pavlo Golub, and I'm a senior developer slash consultant at Cybertec. And today I want to introduce you my new tool, pgcov, which helps DBAs, developers, DevOps, managers to measure the coverage of SQL and PLpgSQL code to know which parts of your code are actually executed during the tests. So let's dance with pgcov. Let's bring some real test coverage to PostgreSQL code. So let me tell a couple of words about my company, Cybertec. I know that Cybertech is a part of a community. It's a crucial part of the community. Everything we do is for people. And most of our tools are open source, and this one is open source as well. Also, as a company, we provide all kind of services. You could find them on our website, and we provide many tools and products, and some of those are maintained by me. So check them as well. Okay, so what is the problem here? This like familiar picture for every programming language we can measure the test coverage for Go, for Rust, for C, C++, just name it. But there is a blind spot. PostgreSQL code has no coverage visibility yet. So we could test database logic. Our tests are passing, CI is green, but we never can tell for sure which parts of our SQL or PLpgSQL code were actually executed, right? So the honest answer here is we don't know. So, and tell me please, why is Postgres different from all other programming languages? Because SQL is a real code. Moreover, SQL is a Turing complete programming language. That means we have all kind of function, procedures, trigger, conditional logics, just name it, loops. We all have it. So PLpgSQL is a real programming language. The problem is we treat it differently. So why coverage is hard in PostgreSQL? First thing is that code runs inside the database engine, and we don't have an access there. And the execution is stateful and transactional. And Postgres itself doesn't provide any coverage hooks and no instrumentation support. And there is no any dedicated tool that could operate on the SQL level. So it's not about we cannot do it, it's not about it's impossible. It's just a gap. There is a gap. We need to fill it. So what we do now, most SQL code is tested with the regression tests. So we have some SQL, then we have some tests, we run those, then we compare the expected output with the actual output. So this way we can test correctness, right? But then again, we couldn't tell you which part of the branches, if or loops were executed. So yes, we tested, our tests are passing, but we have zero information about the coverage here. The other thing is PLpgSQL check, which is the static analysis tool for PLpgSQL. It could help you to check the types. It could help you with linting. It could help you, it could find some dead code. But the thing is, it never runs during the runtime. So it doesn't know about your tests, and therefore it cannot produce the coverage metrics. Another powerful solution here is pgTap. It's the excellent framework, excellent tool for assertions, expressive tests, and then again, pgTap does not answer which branches, which part of the code was executed. So it's great to test the behavior. It's pgTap is great to test results, but then again, you don't know nothing. You know nothing about the execution path. So let's have some comparison table here, right? So for Go, for Rust, for Python, and for other famous and well-known programming languages, we do have coverage tooling, but not for SQL and PLgSQL. Why this matters? Well, the first people that are somehow affected with this are developers. We as developers, we want to know what part of our code are dead, what part of our code are never completed the test. But then again, DBAs and DevOps, they want to know this as well. And I'm not going to say that support managers or higher managers are not interested in the fully covered code by tests. So what coverage means for Postgres? So as a developer, I want to know, is my function ever executed during the tests? I want to know which branches inside the function were executed, means covered, right? And I want to know what kind of errors I ever tested with my tests. So it's not about performance, it's not about correctness, it's about the amount of the code. So how much of my code was covered by the tests. Okay, so at that point, I decided that it's time to create a new tool, and I put some constraints for myself. So first of all, I want this tool to work on every Postgres possible, meaning cloud vendors, vanilla Postgres, timescale DB, just name it. That means I couldn't rely on the extensions. It should be only minimal Postgres. I should not make any modifications to the engines. Otherwise, I will need to support my own fork of the Postgres. I want my tool to be CI/CD friendly, so people with GitHub and GitLab repos could integrate this tool into this repo easily. I want my tool to be um, I want my tool to be I want my tool to work with other tests already present in the repo. So for example, if you were using regression tests or pgdep tests, they should just work without any changes. And I want all tests run fully isolated, so the results from one test shouldn't affect results from other tests. So that's a high level idea. So let's treat SQL as a source code. Then let's do our magic, instrumenting it, then run isolated tests, then we observe execution, and at the end, we just produce the coverage reports, either for human or for some machine, right? So it's a familiar idea. That's how all coverage tools work in the world, but we applied it to unfamiliar place. So let me introduce pgcov, that stands for pg coverage. It brings test coverage analysis to SQL and PL pgSQL. So it's a standalone CLI, one binary, no PSQL dependencies. You don't need any extensions. It integrates well with the CI/CD pipelines, and you could use this tool alongside the pgtab and regression tests. That's easy. Okay, let's see how pgcov works. So first of all, we need to instrument our bodies. What does it mean? That means we need to insert a special statement before every executable statement in our code. Um, in the example here, you can see the original versus instrumented. So we inserted pg notify call, and the first is the name of the channel, pgcov, and the second parameter of the payload is the file name where we have our function we test, then the byte offset from the beginning, and the byte length of the instructions. So no extensions, no changes, just plain SQL. And we don't apply any changes to the source code. We do it on the fly. We read from the files, instrument it, and execute in the against temporary database. So every test get its own private Postgres database. It's just pgcov test and then some date and some random number. Then we deploy instrumented source files. Then then pgcov starts to listen on a dedicated connection for all the signals. Then it executes test SQL files one by one and collect the fired signals. After we're done, we drop temporary database and we're done. So your cluster is clean, nothing is left there. Inside the pgcov, we use listen functionality and for collecting the signals. And we collect all those payloads and build a map of the statements were executed. And yeah, that's it. So let's compare how pgcov fits into the existing toolist. So regression tests don't provide with the coverage the same as PLpgSQL, which is PLpgSQL check, which is a static analysis tool. pgtab also doesn't provide you with the coverage, but pgcov provides you with information about the coverage and nothing else. This is the idea behind pgcov. So how pgcov distinguishes the source code versus test code? It uses the same convention as a Go. So everything that has extension SQL is treated as the source. But if we want to specify the test file, we always postfix. We add postfix underscore test to the name, and this way pgcov knows that postfixed files are tests and other SQL files are source files. Let's do some demonstration here. So let's say we have some minimal product inventory system. So we have products with ID, name, price, stock quantity, category, right? And on top of it, let's say we have some predefined PLpgSQL functions. Add product, which will insert some new products with validation. Get stock status will provide us with information about the stock level, and then we'll have some apply pricing policy function that will allow us to apply some tier-based discounts here, right? So, for example, if we will check the part of our get stock status, so it has several distinct paths. First one is just a check for the error for the if product doesn't exist. Then the other one is checking for the empty shelf, meaning is there any product at all. The next one, where the number of product is less than 10, that means we are running low on this product, and otherwise that's well stocked. So if you want to follow my example, you could find the sources in my GitHub repo, Cybertec PostgreSQL /pgcov. There you will find the examples and demo folder. So we have these three files there. 01 schema, which is just a table, and then 02 functions, which is responsible for our logic. And then we have demo test SQL, which is a file for our tests. Okay, let's run pgcov and see what kind of coverage we do have now. run pgcov, we specify pgcov run. Then the first parameter C, which stands for connection, we specify the connection string to our database. And then as a last parameter, we specify the folder with our SQL files. So you can see the output. It says we have one test passed, total one, and the coverage 50%, and the total time is 592 milliseconds. As you remember, here we have only one demo test SQL. That means we have only one test, right? That's why we have one as total. Okay, so all tests pass, and the coverage is 50%, right? So something is not being tested here. How can we check what exactly we were missing here? So first of all, let's generate HTML report, which is very convenient for us humans. So we do it with the additional command pgcov report. Then we specify the format HTML, and the -o means output. We want to put it into the report partial HTML, right? Then if we open our HTML report, we can see this picture in our browser. For those of you who worked with Go, you probably see some similarities, right? So we have three colors here. The gray color means this is not tracked part of the source. Either it's a comment or a definition line. Then we have a red, means these statements were not covered with our tests. And then we have green lines that say that we have these lines were covered with our tests. And the drop down box in the top will show you the source files that are available during our tests. So at the moment, I opened 02 functions, but you could choose 01 schema and it will be all green because schema files usually always executed, right? Okay, so now we see that we missing one, two, three branches here. So we found, so the output is limited here. So we are looking into one function, but the full result is that we have four uncovered branches at all. So two in get stock status, and two branches are missing in apply pricing policy. That's another function. Okay, in demo test SQL, we have a second do block that is commented out. So if you uncomment it to just see what's changed, so you uncomment to exercise the missing branch, and the commented code has more calls to add product with some additional values. So each assertion here directly targets a line that was read in the previous report, right? Now, if we run pgcov again with updated tests, we can see that the number of tests is still the same. It's just one total, one passed, but the coverage is increased. Now we have 70% instead of 50, right? Let's produce the HTML report again and see what changed. What's changed? So as you can see, we addressed two branches out of three in the get stock status. Now we have almost everything tested except the if not found statement. So this should be addressed separately. So that's how we work with the coverage. We change our tests to increase coverage step by step, unless we have some pretty fine threshold. I would say 80% usually is okay, but that really depends on your product and your repository. Okay, so what we had here, we had 50% coverage. Then we moved to 70, just improving our tests. So what commands do we have here? There are only two commands. It's very simple. It's very simple too. So first one is run, where you could specify the connection string to the database cluster. Then we could specify the timeout. If you don't want your tests to be run forever, you can limit them. We could specify how many parallel tests we could run. We may specify what will be our output file. By default, it's .pgcov cover JSON. And the last one is verbose. If we want to see the progress of how our tool executes tests. And we have another command, which is pgcov report, which allows you to transform the JSON output into the different formats like alcove, which is like integrates well, which integrates well with all providers like CodeCove and other. And JSON is useful for machine reading. Maybe you want to use it with your AI agent, and HTML is intended for people. To run it in CI/CD integration, it's really easy. You just run it in your GitHub action, then you generate the report, and then you send the generated report to the vendor, for example, here in coveralls. So, okay, what pgcov is not? It's not a migration tool. It's not a replacement for pgtab or regression tests. That means you need to have tests to use pgcov. It's not a profiler, it's not a query analyzer. It could take more time to execute instrumented code than to execute just regular regression tests. pgcov is not tied to any ORM framework or language. It could be used easily from every environment you want. And this is very strict and focused tool. This is only for execution visibility, and that's the only thing we want to execute. There are some limitation. First of all, we cannot instrument C, Python, Perl, and other stored procedures code. Um, we don't instrument the per branch attribution. We work with the Postgres 13 or later. You probably could use it with the earlier versions, but uh, I don't want to promise you anything. Just upgrade your Postgres. So for future, maybe we will add merge command, and maybe we'll add fail under option just to produce error if the coverage is low. So yeah, we measure coverage everywhere, and pgcov is here just to allow you to do the same for PL, pgSQL, and regular SQL code. This way we confidently can say we tested everything. So if you have any questions, just then send those to me directly via email or any other social channel. I will be glad to hear any feedback. Thank you so much.